Today, I would like to introduce some sensors which are quite new in range and I think very interesting because they're used in maybe new cars. So especially Euro 6 cars. Euro 6 brought a lot of changes to the car manufacturer at the end, and we got in some new sensors, especially in the exhaust. And I would like to introduce these sensors, not only not all sensors, what you can see here. So Pierburg and we doing since a long time a lot of sensors. Quite common are the air mass sensors or the tank sensors, for example, and the manifold absolute pressure sensors, the MAP sensors. But this is well known. I would like to talk about the latest ones. This is the differential pressure sensors, the back pressure sensors, the exhaust gas temperature sensors, the NOx sensors, lambda sensors, wheel speed sensors, and TPMS sensors. This is an overview of exhaust gas sensors in a car. It's a schematical overview. And you see in the Euro 6 car, there are really plenty of sensors inside the exhaust pipe. So we have several temperature sensors. You can see the temperature sensors in front of the turbocharger, which are located usually close to the EGR cooler, for example. So this can be two. We have one in front of the turbocharger sometimes, one behind, one before the oxycatalyst, one between catalyst and diesel particulate filter, one between diesel particulate filter and SCR, and sometimes also one behind. If the car is equipped with a low pressure EGR system, there may be also a temperature sensor located on the low pressure EGR cooler. So in the worst case, there are 6, 7, or 8 sometimes temperature sensors in a Euro 6 car. And the temperature sensors are not the only sensors. If it is a petrol engine, we have also several lambda probes in front of the catalyst and behind at least. On diesel cars, we have one lambda probe, so also there are lambda probes fitted in. We have differential pressure sensors or back pressure sensors and at least NOx sensors if the car is equipped with an SCR sensor. So really a high amount of sensors inside the exhaust. So if we have a look on the sensors more in detail, in the exhaust tract, we have temperature, pressure, oxygen, and nitrogen oxide sensors. These are the exhaust gas temperature sensor, the back pressure, the differential pressure sensor, the lambda sensor, the NOx sensor. In the air supply, we have the MAP sensors and the air mass sensors. In the fuel supply, we are speaking about the tank level sensor, the fuel pressure sensors, and miscellaneous from our side. Because it has nothing to do with the engine directly. It's the TPMS sensors and the wheel speed sensors, also called ABS sensors. So, starting with the lambda sensors, first of all, some key facts. Lambda sensors measure the residual oxygen in the exhaust gas. This measuring, it's a voltage measuring, gets calculated into the lambda signal, which is around 0.7 and 1.3 lambda in regular engines. On direct injection engines or in diesel engines, it's a little bit different, but there are different types of lambda sensors also used. Lambda sensors are needed to operate or to calculate the correct mixture and to operate the catalytic converter at the end. So this is what happens in the catalytic converter. So the catalytic converter converts carbon monoxide, nitrogen oxides, and hydrocarbon into normal gases, which are not unhealthy anymore. The three gases before are very unhealthy. They are toxic, so they have a direct influence to our health. So the catalytic converter converts carbon monoxide, hydrocarbon, and nitrogen oxide to water, carbon dioxide, and the nitrogen at the end. So for this operation, the lambda sensor is needed. So to get the catalytic converter working correctly, we have to have a specific mixture. It's called lambda 1 usually, a little bit above and a little bit below. So it's always a changing signal where we have a little bit too less air in the exhaust and a little bit too much air in the exhaust. And I did it opposite wrong. So it should be too less air in the exhaust and too much air in the exhaust. So it's always changing. So the amount of air has to change because the three-stage catalytic converter converts on the rich mixture the nitrogen oxides. So it's and on the lean mixture side, where we have a high amount of oxygen inside the exhaust, it oxidates the carbon monoxide and the hydrocarbon to carbon dioxide and water at the end. So we have these two functions. That is why the mixture must be always changed and must be well known by the engine, that this calculation can be done. And the mixture is always in the right condition. This is be done by the lambda probe in front of the catalytic converter. So there, the lambda probe measures the amount of oxygen inside the exhaust, and this information is needed to set up the mixture correctly. On the behind of the catalytic converter, we have a second lambda probe on petrol engines. This lambda probe is needed because the car manufacturer needs to know how the catalytic converter is working. And this information is also very important for the engine ECU for proper operation, because this is the part where we get the information if the part is working correct or not. We have two parts, two different kind of lambda probes mainly. One is the jump probe. This is what I described before. It's a probe which measures the oxygen inside the exhaust and gives a voltage signal to the engine ECU, and the engine ECU calculates the lambda at the end. Very lean operating cars like direct injection engines on the petrol side or diesel engines, we are using wide range lambda probes, which works a little bit different. So wide range lambda probes do not produce some kind of a jump signal. It's a linear output signal they produce, and they are working very different because they do not produce a current, a voltage directly. They needs a current for the operation. So this is a little bit different. And the wide range lambda probes are used in cars where we only have lean mixtures mainly. So with the jump probe, we are able to measure lambda ranges up to lambda 1.3. With the wide range lambda probe, we are able to measure lambda rates up to lambda 10 approximately. So especially on direct injection engines and diesel engines, that is needed. So if we have a look to the jump probes, there are different kinds available, especially on very old cars. There have been one-pin lambda probes available. So there was just one pin. The mass or the ground was the chassis, the exhaust pipe on this probes. And yeah, this is usually not any longer used. It's really just in older cars. On later cars, we had 2-pin lambda probes at the end. And the difference between the 1-pin and the 2-pin was that the second pin was the ground for the lambda probe at the end. So there was no ground via the exhaust pipe, where we have a lot of problems with because of corrosions, heat, coldness, and so on. So this is always difficult to handle. So we have the 2-pin, the ground separated, and this leads to a higher durability for the part itself. So lifetime is higher, and the measuring is more accurate over its lifetime. The 3-pin lambda probe is currently sometimes also in use in some cars anymore. So the difference to the 2-pin lambda probe is that now we have 1 pin for the signal voltage output and 2 for heating pipes. So this part has a heater inside to keep water away from the measuring, and this is where 2 cables are for. So we have 2 cables plus minus for the heater and 1 for the signal. On the 4-pin lambda sensors, it's all separated. So we have 1 signal for the voltage plus output, 1 for the earth, and 2 for the heating pipes at the end. So this is what's more or less common today. If you find a 6-pin lambda sensor on a car, it's always usually a wide range lambda sensor, because the wide range lambda sensor needs 6 pins, 2 for the heater, 2 for a reference signal, and 2 for the current at the end for the activation signal. And this is why 6 pins are needed. The monitoring of the catalytic converter I mentioned before is usually always done with a jump probe. It's very cheap. A lambda probe, usually from production, the wide range is more expensive, so they use always only what's needed usually, and this is a jump probe, so it produces the same signal as we see on the first lambda sensor. So it kind of measures the oxygen inside the exhaust, and if the oxygen is low inside the exhaust, the voltage increase. If the oxygen in the exhaust is close to the oxygen around on the outside, the voltage drops. So as higher the difference, as higher the voltage the lambda sensor produces, and the monitoring is quite easy. If the catalytic converter is working and has no fault, the oxygen in the exhaust is needed to do the oxidation inside the catalytic converter. So we oxidate oxygen with carbon monoxide to carbon dioxide. We make an oxidation with the hydrocarbon. So the hydrocarbon gets separated into carbon, oxidates with the oxygen to carbon dioxide again, and the hydrogen is oxidated with the oxygen to hydro to water, to hydrogen at the not hydrogen, sorry, to water, H2O, and so the oxygen inside what's inside the exhaust is taken, is needed. So at the end of the catalytic converter, there should be not that much oxygen as before, and it should be similar line, even if it is higher or lower, but it should be more or less always the same. Not that what we see here, up and down of the voltage, it should be more like a line. And the fault gets detected when the second lambda sensor starts to gets a signal like the first one. So if this part is faulty and the oxidation couldn't be done, the second sensor measures the same what the first measure, more or less, because the oxygen is not any longer taken inside the catalytic converter. And this is how the car knows that there is something wrong. Maybe it's broken or yeah, very old, so anything should be wrong. So this is very accurate measuring. Yeah, it looks like here, so you can see the animation. So if the signal looks like that, it's functioning. You see the higher peaks, and here it is more flat. And if it becomes similar to the first signal, then the catalytic converter is definitely faulty. The wide range lambda probe is hard to diagnose. So if we have a wide range lambda probe, it's needed to use a diagnosis machine for the diagnosis, because the wide range lambda probe works with the voltage. So we have more or less two sections inside the wide range lambda probe. We have one which is a regular jump probe and one which is a measuring probe, more or less. So the oxygen from the exhaust get pumped into the reference channel of the probe. There, we want to have always a lambda 1 signal, and then the current which is needed to transport the oxygen from the exhaust into the measuring chamber. This is our data for the let's say for the lambda at the end. So we need a diagnosis machine on jump probes. It's quite easy. We can use a multimeter. Yeah, just a very brief and quick introduction of lambda sensors. The next are the exhaust gas temperature sensors. And here we have seen really a lot of sensors inside the exhaust pipe. And this is needed by the Euro 6 legislation, because the Euro 6 legislation requires a stricter control of the diesel particulate filter. And this is where we need at least a minimum of 3 temperature sensors. So the Euro 6 needs to know the temperature before the catalyst. The Euro 6 needs to know the temperature between the catalytic converter and the diesel particulate filter, and after the diesel particulate filter. This is needed for the regeneration, because the regeneration needs heat, 600 degrees. It's depending on the system, but usually approximately 600 degrees. And with the temperature sensors, we measure the temperature curve inside the exhaust during regeneration, if it is enough to fulfill the job at the end. The same with the broadband or wide range lambda sensor, which is also fitted in diesel engines, Euro 6 diesel engines. The broadband lambda sensor measures the amount of oxygen during regeneration of the particulate filter to make sure that enough oxygen is inside the exhaust to oxidate all the soot particles. Because if we regenerate the particulate filter, it's some kind of burning, an oxidation, and therefore, of course, oxygen is needed. We also use differential pressure sensors or exhaust gas pressure, back pressure sensors, or both, to monitor the load of the particulate sensor. And at least some cars has a soot particle sensor, which detects excessive soot emissions. So also the soot emissions are directly monitored. So really a strict control of the diesel particulate filter. And here we see the exhaust gas temperature sensors again. And this is really good business, not only for wholesale, also for the workshops, because the environment inside the exhaust pipe is very hard for every kind of sensors. So sensors located in the exhaust pipe starts failing quite often on a regular basis, maybe. So it's really, really a very bad environment, and this is good for business, for all of us, for you and for us as well, and for our customers. Yeah, from the diagnosis point of view, it's nothing complicated at the end. So exhaust gas temperature sensor measures the temperature. So it's only a temperature sensor, nothing special. So we have two pins because it's an NTC or PTC sensor, a negative temperature coefficient sensor, or PTC, positive temperature coefficient sensor, which means on an NTC, as higher the temperature gets, as lower the resistance. On a PTC, as higher the temperature gets, as higher the resistance. And we don't need exact data. It's enough usually to use an ohm meter, or we measure the voltage drop with a voltmeter. This also works, but the ohm meter should be the easiest way. And if we start the engine and accelerate, and the exhaust gas gets warm, we can measure the resistance, and if it increase in a linear way, then the sensor should be okay. The same if the temperature decrease in a linear way, then it should be also okay. If there anywhere a break is inside the output signal, or the output signal gets lost or starts jumping suddenly, then the sensor is faulty and has to be replaced. That is quite easy to measure, and there is not that much equipment needed. We can also check the data with the diagnosis machine. If we check the IST data, the current data in the ECU, which shows us as well the temperature data of each sensor at the end. So the exhaust gas temperature sensor, as I mentioned, is needed for the stricter control of the diesel particulate filter, but also it's needed to operate the SCR catalyst, sometimes the oxy-catalytic converter as well, and the turbocharger. So that's the reason why there are sometimes much more than these three I mentioned inside a car. And I've seen a Fiat, it's some months ago, where 12 temperature sensors was inside the car. And as I mentioned, the diagnosis is not the worst thing. The worst thing is for a customer to find the right part in a catalog at the end. So this is sometimes not that easy. Yeah, the exhaust back pressure sensors and the differential pressure sensors. These are two different sensor types which are used often in the same function. So exhaust back pressure sensors, not only protect the engine and turbocharger from excessive pressure, they also need it for the engine control to operate the engine correctly, to prevent knocking, or to control the valve timing. For example, if you have a valve timing, what you can change. In diesel engines, it's normally used to operate the turbocharger and to operate the diesel particulate filter, and sometimes to control the cooler of the EGR systems at the end. Looks like that. So it's a pressure sensor, which is well known usually. It's a piezo inside. So if pressure builds up, the piezo gets pressed, and as more pressure, as higher the output signal of the piezo. This is very well known usually because the MAP sensor and all pressure sensors mainly are having the same principle behind. So a back pressure sensor normally is always used if we do not need a reference data, as we have on cars or systems or parts where we use a differential pressure sensor. So the difference to the back pressure sensor is that the differential pressure sensor not only measures at one point the pressure, the differential pressure sensor measures the pressure on two locations. So we have one sensor and one connection is the high pressure connection, more or less, and the second is more or less a low pressure connection. So usually we have on one side a higher pressure and on the other side a lower pressure, and the sensor measures only the difference between these two locations at the end. So this is needed on parts or at parts where the pressure behind the part could change. For example, if you have a particulate filter, as we've seen before, so in older cars, there's nothing behind. So there's only the exhaust pipe to the environment. So the car manufacturer can assume that there is all the time atmospheric pressure. And we have a barometric sensor inside the engine ECU. So the atmospheric pressure data is available. So there is no complicated, expensive sensor needed to measure a difference. On cars where we have, for example, behind the particulate filter, an SCR catalytic converter or an NOx storage catalytic converter, these creates also a little pressure into the exhaust. So this means that the car manufacturer in this case needs to know how high the pressure is on the back of the particulate filter and on the in front of the particulate filter to calculate the correct load, because we want to know how full this part is, how high the pressure is, this part only produce, not the parts behind, only that part. The same with the EGR cooler on the low pressure side, for example, to monitor the EGR cooler if it is clogged or if it is maybe broken inside. Here also we use differential pressure sensors because the pressure varies on both sides. It's varying on the throttle we've seen here, the exhaust gas flap, the EGR valve, and much more. So the pressure is variable on both sides, and that's the reason why we need the differential pressure to get a proper idea of the function of the cooler at the end. So differential pressure sensors measures the pressure difference before and after a component. Less frequently, pressure difference to the environment. This is also what some manufacturers do. They save money because they do not connect the second connection. So they only use a differential pressure sensor to measure the pressure in front of a part and not behind. So the connection is only open. So it has a connection to the atmosphere. So this part is now working as an exhaust gas back pressure sensor, not any longer as a differential pressure sensor, but it's cheaper to use the differential pressure sensor because they have ordered it in high quantities maybe. And they use it now in this way. The money they save is related to the software, because the regulation, the calculation and everything is easier and the software is easier. And software also costs money. If the car is quite new or development has been done new, the back pressure sensor is in use normally because it's the more cheaper part than the differential sensor. Yeah, also on petrol cars with particulate filters, these cars are getting used, and yeah, this is nothing new. Important for the diagnosis, maybe the differential pressure sensor has always to be teached in. So we need to do an adaptation to the engine ECU. We have to tell the engine ECU that there's a new one inside. Normally, this has to be done every time. The issue here is if we do this adaptation and we recognize the sensor wasn't faulty, please do not use the old sensor in the adapted system. That is important because we cannot make the adaptation backwards. So the engine ECU calculates with the data of the new one and not with the old one. So if we put the old one inside, that can cause a problem relatively soon. So if there's a new one inside and you have done the adaptation, then you should keep the new part inside the exhaust. Sometimes we have also design changes. So this is an adapter cable which is needed for a specific part number of a back pressure sensor. The reason here is that the manufacturer, and this sensor is used in Mercedes, Nissan, Dacia. The manufacturer, one of them who produced the engine, changed the design of the plug connector. And you see here the old version and here the new version. And that's the reason why there is an adapter cable is needed to connect the new one with the old one. It's sometimes confusing because people who order the back pressure sensor thinks, oh, it's the wrong part number because it doesn't fit the car or the electric side of the car. But this is unfortunately a design change, and we have to do the work to implement the adapter cable as well. There's also an information available. So every customer who uses TechDoc or our catalog, or usually every catalog, there is a remark inside that there is a service information available, and we should see that there is special information and give this information to you in best cases with the cable. But sometimes our customers are not aware that this information are important and forget it. So if you have some kind of this, and it's not only related to the sensor, if you see that there is a design, that it looks different, and the catalog says it's the correct part, maybe check with the car dealer, with the parts dealer, with their catalog, if there's information linked to, or check with our motor service app or with the motor service homepage if there is an information available. There are search functions on the site and on the app, which makes it easy. Yeah, NOx sensors are quite new, and NOx, nitrogen oxide sensors, are very important to operate the SCR system. SCR, selective catalytic reduction, also called for many people AdBlue system. AdBlue because this is the fluid which is used to operate the system, and everybody knows it because we have to refill it and we have to buy it, and that's where the name comes from. But originally it should be an SCR system. So the SCR system reduced the nitrogen oxide exhaust of a car, and to monitor this, the NOx sensors are needed. On diesel engines, because otherwise the engine ECU is not able to dose the AdBlue in a proper way. So the engineers who need the information, how much nitrogen oxides is in the exhaust to keep the system running properly. For direct injection petrol engines, the NOx sensor also is needed to monitor the catalytic converter, for example. On petrol engines with direct injection system, the benefit of this injection type is that we can operate the petrol engine with a lean mixture. So if we drive on part load, these engines sometimes are operated like a diesel engine with a high amount of oxygen, and the power is only regulated with the amount of fuel. So these cars produce a lot of nitrogen oxides as well, and they have special catalytic converters like the NOx catalysts integrated. And also here, we need a sensor to control and to monitor the system at the end. This is usually on Euro 6 cars, so on new cars really, but Euro 6 is approximately 10 years old now, so the cars are not really new anymore. And it's not only on passenger cars, what I mentioned, it's always also on trucks, on light commercial vehicles, or on heavy commercial vehicles. The NOx sensor, the working principle, is on the first glance of view quite very complicated, but at the end, not that complicated anymore. We have two measuring chambers, more or less, two chambers where the exhaust goes through. And from the exhaust, we get nitrogen oxides and oxygen inside the first chamber at the end. And here we have anything very similar to the wide range lambda probe. So it is an O2 pump. I told you that on a wide range lambda probe, the oxygen gets pumped into a measuring chamber. And here we use the same pump. So a current operates the pump, and the pump sucks, or not sucks, brings all the oxygen, which is not connected to the nitrogen, out of the chamber. So the oxygen gets transported to the outside. So a little bit of this oxygen must stay in the chamber, but only a very few oxygen particles, not that much. After this is done, the exhaust gas gets into the second chamber. And here we have the same. We have again an O2 pump, which is number 8 on this slide. And also here, a current operates the pump. And now the oxygen, which has left inside the exhaust gas, not pumped out here, gets pumped out. This leads to the effect, if there's no free oxygen inside the chamber, that the oxygen from the nitrogen oxide gets separated. And now the third pump starts working, also with the current. And this pump gets the current, gets the oxygen, which now separates from the nitrogen oxides into the reference chamber. This is this one. And here, then this is connected to the outside. So at this end of the sensor, we have only nitrogen and oxygen. So nothing harmful. The oxygen from the nitrogen has been separated. And this data calculates the amount of nitrogen oxides, because as much more oxygen gets from the nitrogen oxides, as more nitrogen oxide is in the measuring chamber at the end, in the chamber. The principle is not that complicated, but the control of this part is extremely complicated. That's the reason why many car manufacturers sometimes there's problems with these parts, because it has to work all very accurate, and this is really, really hard to do and to operate to make it functioning at the end. From a diagnosis side, it's also not easy to test nitrogen oxide sensor. So nitrogen oxide sensor needs plus and minus at the end, because we need the electrical connection. So we have 2 pins for plus and minus. This we can measure with a multimeter or whatever. So we can see 5 volt or 0 volt at the end. So if there's anything wrong, we can measure it. But the signal itself, everything what you see here, is done by the sensor itself. So the engine ECU is not in charge. The engine ECU communicates with the part itself via a data bus signal. The data bus signal, it can be a CAN bus signal or a LIN bus signal. So it's usually a data bus signal mostly. So sorry, a CAN bus signal. So they have 2 pins for the data bus. It's a high and the low voltage pin there, and we cannot measure the data bus signal properly. So we do not know if the signal which comes out is correct or not. We can only check if there comes a signal out with an oscilloscope, and we can make measuring on the cable. We can measure, for example, the resistance for the data bus. So if the end resistor is okay, we can measure a voltage or a ground connection of the cables, but that's all. So usually we need to trust the failure code and make sure that no other fault can be the reason for this failure. So we examine all other failures, and then it should be the nitrogen oxide sensor at the end. So also here, an information is inside the box where you get further information. Yeah, sometimes the pin connector is described. There is the tightening torque usually inside the box. And if there is a specific information available, it's also linked to the catalog. So normally the replacement itself is not a big problem. It's mostly plug and play, nothing else. Yeah, TPMS sensors, tire pressure measuring sensors. This is also available since some time, and here only first of all the differences. If we are use tire pressure measuring systems, we are talking about 2 different systems. It's first of all the active and the passive system. The active system means that we measure the pressure and the temperature of every wheel directly. So there's in every tire a sensor who makes this measurement, and these data are getting transferred to a control unit with a wireless LAN signal, more or less. So it's 433 megahertz in Europe. This signal is used to get the data to the control unit. The US use 315 megahertz, but 350 megahertz are forbidden in Germany or in Europe, because the frequency band is reserved exclusively for military applications. So in Germany, it's not allowed to use that. It's always 433 megahertz signal. The sensors itself, there are different types available. The OER sensor, which means It's a OE replacement sensor, OE replacement sensor, which means it's quite easy. It's plug and play. Yeah, so it's just replacing one sensor for another. Teach the system with the car on, and then it's usually done. There are also universal sensors available, which has to be programmed. So this is quite complicated sometimes to program these sensors to the ECU. On our side, we are only dealing with the replacement sensors. So this is usually not that hard work to replace the sensors, because there's no programming needed, except the programming inside the car, where you have to say, okay, the tire pressure is measured. Two different types are available, clamp in and snap in. This is the one is with union nut and the other is snap in. So one is with a screw to make it easy, and one is like a normal air valve in a tire, which snaps in its seat at the end, and that's all. This is active, so the difference from active to passive is quite easy. Passive sensors or passive measuring of the tire pressure means we use the wheel speed sensors to measure the wheel speed and calculate an air drop of the tire into it. So later, a little bit more when we're talking about the wheel speed sensor. So this is only a measuring about a pressure drop, and this can tell us exactly how much pressure is inside the tire. Yeah, this is how it looks like. So we have the TPMS sensors, the active one, inside each tire. We have the control unit, and we have the radio signal, and the signal gets transferred to the control unit, and the control unit informs the driver is connected to the dashboard, and if there's anything wrong, the car driver gets informed with these sign at the end. Yeah, also some cars, if we have active sensors, shows the data, so we can see the air pressure on every sensor directly. Yeah, the sensor itself is battery powered. Battery powered means there is a battery inside which cannot be replaced. That is the good and the bad story at the same point. The bad, because it cannot be replaced. So after years, the battery will run empty. And if it is empty, we need to replace the complete sensor. So after 10 years, approximately 250,000 kilometers, which is approximately 160 miles, a little bit less, the battery has to be replaced. And on a car which is that old, where the first sensors are inside, when the first sensor starts failing, I would prefer to replace all sensors, because all other sensors will have the same failure in a very short period of time after that. So this is sometimes nice to know. From the diagnosis, the only possibility we have is to use a diagnosis tool, which can measure these data. So we can measure the data on every tire and check if it is correct. If the data is correct, the failure must be anywhere else. If the signal is incorrect, it's missing, or the data are wrong, then the sensor usually has a fault, and this is the most common fault. Usually, it's the sensor itself where the battery runs empty or where we have a failure inside at the end. So, but this can only be done usually with a specific diagnosis machine, which can measure or can interpret the signal of each separate sensor. So we measure each tire, and then we know what's happened. Yeah, this is just a picture. This is a snap-in sensor, and this is the one with the screw, with the union nut. Yeah, advantages. It's plug and play. That is the most important. So there is no programming needed, and that's all. Yeah, the wheel speed sensors. It's our latest program, our latest new product, what we have. And yeah, wheel speed sensors are well known. Since the 80s, most cars has a wheel speed sensor because the ABS system occur. So there are different versions available, active and passive sensors. Sensors with cable or without cable at the end. The difference is at least in the signal output, because this is important, what the car manufacturer needs to have because of regulation. This is a little bit different. So a passive sensor is the oldest version, more or less. It's a passive sensor, so we have no voltage supply on the sensor directly. The sensor produces its own voltage, so it's our output signal, what we have. So there is a magnetic ring at the tire, and this means if the tire is turning, the magnetic ring turns, and the magnets on the ring inducts a voltage into the sensor itself. So we have the voltage, we have no voltage, we have the voltage, and as quicker the tire turns, as quicker is the change of the signal at the end. So these sensors are working very well usually, but the problem is the car does not know which direction the tire is turning, and the signal starts to be accurate from approximately 7 kilometers per hour. So 7 kilometers per hour, 4 miles, which is especially for modern cars, not any longer state of the art, because we need to know from the beginning and the direction, the speed and the direction the car is moving, forward or backward. So this is where the active sensors comes into place. So the speed sensors, which are active, they need a power supply. So there is an IC chip integrated, and we have also magnets on the other side. The signal gets, how to say, it's not only the signal what it collects from the sensor. The signal gets changed into a signal the car manufacturer needs. I can show you here a little bit better. 1 second. It looks like here. So we have a rectangle signal, a PWM signal, or a data bus signal at the end. So the data bus signal is the RS232 signal. You know that from your comparator. It's where the internet connection works with usually. So with these different types, the car manufacturer can implement functions. For example, the rectangle signal is it's some kind of PWM signal. It looks similar, but it's more frequency we get. With this frequency, the car manufacturer knows only how fast the tire is turning, not the direction, or anything else. If the car manufacturer uses a PWM signal, he can transport information with the PWM signal. So it's not any longer a frequency. And this means that the car manufacturer knows the direction of rotation, or if the car stands still. And this is often needed also for the ESP, for start-stop systems, and so on. So this information is needed. And if they use the data bus signal, then the car manufacturer is able to receive a lot of information, because with the data bus protocol, he can add really every information he wants to have. It's totally flexible for the car manufacturer. The AK protocol has also the advantage that data bus signals are has no interferences with anything else. So if there's a mobile phone or whatever, anything what's disturbing the signal on data bus signals, it's not that problem. On frequencies, PWM signals or analog voltages, and sometimes it can disturb the signal, and could lead to the effect that the signal is not proper received by the ECU. So this is the advantage of the data bus signal, but most of the sensors are using the PWM signal. For us, if we do the measuring, it's not that important, because it's usually a signal which is always similar. So we do not have that much change. As quicker the engine rotates, the tire rotates, as quicker the signal is, or as higher the pulse modulation is at the end. So we can measure it with an oscilloscope, works very well. But we also have to recognize the magnetic ring on the other side. So there can also be a fault. Yeah, on the tire pressure management system, here the working principle at the end. So if we have in all tires the same pressure inside, the wheel speed of the tire is the same, more or less, because the diameter of the tire is on all the same. If one tire lose air, so air drops, the diameter gets smaller. And if the diameter gets smaller, the rotation increase. So this tire turns faster than the other. So this is how the calculation of the tire pressure works. If one or two maybe tires varies its speed compared to the other, then the system knows there's something wrong, and the TPMS light switch on. The difference to the active system is the system does not know why. It's just just a suggestion, more or less. It doesn't know exactly what's wrong. It just only know that the wheel speed is changed and not correct compared to the other one. So this is the working principle in the TPMS system. It's quite easy. No additional sensor is needed. The sensor ring is all inside the car. If we refill the air, we have to program, we have to set up the system with the dashboard. It's quite easy. This is very simple system compared to the active tire pressure measurement. Yeah, there's again the tire pressure management sign or light, and that's all so far.